Hey everyone, let's start with another lecture video of CS2505. So yeah, let's get started. Today we are going to take a look at the identifiers, and if you already have a Java background, most of these concepts will be very old to you, but there are some new stuff, so don't just ignore it just because you already know it. Okay, so yeah, let's get started. The three attributes of an identifier. So what is an identifier? It is a name of a variable, name of a type, name of a function, right? And identifiers have like three essential attributes: storage duration, scope, and linkage. This will be our main topic of this lecture. So yeah, let's see. So at first, declaration and definition. A declaration specifies the interpretation and the attributes of set of identifiers. A definition of an identifier is a declaration for that identifier that for an object causes the storage to be reserved for that object. For a function, includes the function body. For a enumeration constant is the only declaration of the identifier. For a type def name is the first or only declaration of the identifier. So this is just like the definition of the definition. Okay, so the main idea is declaration is basically like, whenever you're writing a function and like for example void print int x or something. So this is your declaration, right? And definition of an identifier is the declaration of the identifier. I mean, you get the point, right? This is just a formal definition of definition and declaration. So let's focus on the more important stuff like storage duration. So okay, so storage duration. This determines when during execution of a program memory is set aside for the variable when the memory is released. Okay, so automatic duration. Storage is allocated when the surrounding block of code is executed. Storage is automatically deallocated when the block terminates. Okay, so first focus on the automatic duration. So this is the most common one. You already know about it. For example, we have a while loop. Okay, so we have a while loop over here, and I am declaring in equal to 10 over here, and then I'm just like doing this. So this int a has the automatic duration. It starts from here, and whenever it gets here, like outside the block, it disappears. Okay, so when we enter this for loop, it is going to exist while the for loop runs. And whenever the for loop stops, it's going to stop existing. This is the idea of the automatic declaration, sorry, automatic duration. And whenever you go outside the block of it, that variable stops existing. Like over here, if you try to access a, it will say that it doesn't exist because right after it crossed the block, it stopped existing. That's how automatic duration works. The other one is static duration. Static duration is storage allocated when the execution begins. The variable stays in the same storage location as long as the program is running. Variable can retain its value indefinitely until the program terminates. So that idea of static is same as the static in Java. Like you had the static identifier in Java, and if you used it, you know that whenever you start the program, it starts existing, and when the program ends, only then it stops existing. Okay, so in C, the idea of static is more or less the same, but sometimes it can be worked differently. In the previous lecture, you have seen that if you declare a function as static function, it becomes a file scope. We will look at file scope more closely in this lecture. Okay, so automatic storage duration. So we already talked about it. So for example, this is a sort function, and we have a start index. So this start index has the automatic duration. It starts existing from here, and whenever it goes outside of here, it stops existing. Okay, so default for a variable that are declared inside a block created, like the memory is allocated whenever this call is, like function is called. For example, whenever you call sort, a memory is allocated for this start index, and whenever the function returns, it stops existing. It is initialized on each call, and it is deallocated whenever the call ends. Okay, so that's the idea. Like it works the same way for every single block. It can be same for like function call, or like any sort of like loop call, like while, for, do while, if else, even like switch. So what happens over here is like all of these have some sort of block, right? So whenever there is some sort of block, the automatic duration is kind of a default, unless it is something else. So let's take a look at an example of static. So over here, we are declaring this variable as static. Okay, so this is kind of interesting. It basically means that whenever this function is called, the variable num swaps is always going to hold on to its previous value. So default for variables declared outside of all blocks, initialized once, keeps its value until the program ends. Variable is declared inside a block with the keyword static. Initialized once keeps its value from one call to the next. Okay, so how it works is, for example, it starts with 0, right? And imagine there is something like num swaps plus plus. Okay, so I'm going to call it once, and after the call, this is going to turn into like 1. Okay, if I call sort again, this time it's going to be 2. If I call sort again, it's going to be 3. So to understand it better, try to write a code yourself. Write a function. Inside that function, declare a variable with static and print it. After printing that value, increase the value by 1 or something like that. Now keep calling the function over and over again and see what happens. Honestly, you should give it a try just to understand how static works for a variable. Okay. So now let's take a look at the scope. You should be already familiar with the idea of scope. So scope is of an identifier the range of program statements within which the name is recognized as a valid name. So there is block scope. Name is visible from its point of declaration to the end of the enclosing block. Place declaration of name within a block. So just like you can just think of it as automatic duration, like whichever variable has the automatic duration, that is a block scope. Now let's take a look at the new concept, which is file scope. This concept was not available in Java, like not directly. So how it works is name is visible from its point of declaration to the end of the enclosing file. Sorry, my bad. So yeah, sorry, I had a call. Name is visible from its point of declaration to the end of the enclosing file. So it basically means that it's going to start existing wherever it is declared, and within the file it can be accessed by everything that is available in that specific file. Place declaration of name outside of all blocks, typically before any blocks. Like it is basically like where you want to place it, like wherever you want to call it, make sure that it is before that. Okay, So let's take a closer look at block space. And so, like I said, block space, think of it as a like automatic duration, but not necessarily. Okay, yeah. You can think of block space as a automatic duration. So because, well, can you? Well, not necessarily. That's my bad. So yeah, you cannot think of block duration as a automatic. Sorry, block scope as a automatic duration, because it also works for static as well. For example, um, this num swap cannot be accessed from outside of this function sort. It can only be accessed from within. Okay, so this num swap also has the block scope. It can only be accessed within this part. Then we have the start IDX. We can access it throughout the code till the end of it. And then we have this stop IDX, which can be accessed within this for loop only. So that's how block scope works. Like if it's enclosed within a block, that's where it can be accessed. After that, it won't be able to access. You already know this concept from the Java, right? Let's take a look at the file scope. So think that this is your whole file. Like for example, let's call it like sort.c. Inside that sort.c, we have a variable, and within this sort function, you can actually access it. Okay. And not just that, if it had some sort of function over here, like void compare and some parameter, even within there, you can actually access this num calls to sort. So a file scope is a name declared outside of all blocks. Name can be referred from any function within the file. It is potentially very dangerous because it can be changed by anyone, and you should be avoiding it. So and it is better if you use variables by sending as parameters instead of using the file scope. It can be used sometimes. There won't be any other way other than using a file scope, but most of the time it's best if you actually avoid it. Okay, so one idea is file scope can be thought file scope can be thought as a global variable, because everyone within that function can access it, and the value of that variable is going to persist. Like I said, over here in the sort, imagine I'm just doing something like num calls to sort equals like 10, and if I print it here, I will see that it actually changed. Okay, give it a try. Like write a file by yourself, and in that file put a variable on top of it, set it to any variable you want, and try to change those variables inside another function and try to print it and see how it affects the other functions as well. So as the biggest problem in this case is, like, as everyone can change that like variable, it is kind of dangerous to work with, because like if you ever mistakenly change it somewhere else, the output is not going to be what you expect it to be. Okay, so now let's take a look at linkage. It determines the extent to which the name can be shared by different parts of the program. There is external linkage. Name may be shared by several or all files in the program. Internal linkage. Name is restricted to a single file but shared by all functions within the file. And there is no linkage. Name is restricted to a single function. So let's take a look at the external linkage, which is name may be shared by several or all files in the program. So again, we are going to use this function. So this is the file scope, right? And name is declared outside all blocks. Name can be referred to from other files. Okay, this is what we call a global variable. Then there is the internal linkage. So if you put static before that name, it cannot be accessed by files other, like it cannot be accessed by other files. It can only be accessed from within that specific file. Okay, name is declared outside all blocks using reserved word static, and name cannot be referred to from other files. This is also dangerous and you shouldn't be using it. No linkage, which is you are actually declaring it within this function. In that case, if no one outside this function can actually access it. Name is declared inside a block. Name can only be referred to within the block the declaration is placed. Okay, so so far you have seen the concept of like duration, and then there is like scope, and later you saw linkage, and you realize that all of them are kind of interconnected, right? But like they cannot be divided completely. They kind of intersect with each other with the concepts. So determining the attributes, the default storage duration, scope, and linkage of a variable depends on the location of its declaration. So if it's inside a block, it is a automatic storage duration, block scope, and it has no linkage. If it is outside any block, if it has like static declaration, then it will have static storage duration, it will be a file scope, and it will have an external linkage. And so that is the default. Okay, so these are the default storage duration and linkage and scope of variables that you do not specifically specify. So there are other like identifiers that you can use to make them act differently. For example, if you do not want this specific thing to happen, like for example, inside a block, it's going to have an automatic storage duration, and it will have block scope and no linkage, right? Maybe you do not want that. Maybe you want the like storage duration to be static. So in those cases, you have some identifiers, for example, the static, or you can actually specify it to be auto. And there are other ones like extern and register. Extern is not necessary anymore. It kind of is done by the compiler itself, but like still it is for the backward compatibility. And register is to make a variable run faster, but the code will be running faster if you have the efficiency correctly, and using this identifier is not going to make it more faster than it already is. Like it is faster, but like not the way you think of it. As when we go through assembly, it will make more sense. So the global symbols, I have already mentioned that those variables were global variables or global symbols. So what do they mean? This name has external linkage. References to the name are handled by the linker. Compiler and linker have relevant rules for function names and for variable names. So for function name, functions not defined locally are assumed to be external. So compiler leaves resolving them to the linker. Okay, so in the previous lecture, you have seen how to have different like how can you have like separate files for functions. So what happens is all the functions which are not like defined locally are assumed to be external, and if they cannot be found out, they have something called a tag. Okay, so compiler leaves a tag on them and tells the tells the OS that, okay, I think this function can be found somewhere else. And when you put that function or like source code during the compilation, that's when it is actually replaced. The tag is replaced by that specific function. So triggers implicit declaration warning and frequently link time errors when the actual function interface does not match the implicit one. So if you do not have the exact function implemented, it will have a warning or some sort of error. Global functions should be declared in the header file. That is a good practice. It is not necessary, but it's something you should be doing. otherwise we will not get a job. For variable names, variables not declared locally are treated as errors. Must use extern declaration for global variables defined elsewhere. Because if you do not have the extern declaration, it is kind of hard to find. By specifying extern, you are telling the compiler that this variable exists somewhere else. You should go and find it. So let's take a look at like how function names differ based on what specifier or like what type of identifier you're using. For example, if you're using static before it, it defines local symbol function one, it is not global. So this is like file scope, okay? Outside this file, this function cannot be accessed. If it doesn't have a static, this is a global and can be accessed by anywhere in the whole project, okay? Now we have like static void function, defines no symbol and declares function 3. And then we have like extern void, okay? By doing this, it actually tells that it is somewhere else. For function, extern is not necessary because compiler will be finding it out itself. But extern is more necessary for the variable names, okay? So let's take a look at how the identifiers work on the variables. So we have like static int x. So we already saw how it works. It is declared once and it parses throughout the whole program. So it defines a file local symbol of x and y in this case. If we put just like int w, it defines a weak global symbol, aka common symbol. So this one can also be accessed throughout the file, but something you should avoid most of the time, okay? It is being called strong, but honestly there isn't much difference between these two. The only difference is it actually has a value and it doesn't have a value. But if you like put a value of it in some other function, it's almost the same thing. They work as the same thing, but it is called weak just because it doesn't have a value, and usually it is initialized with 0. And the other one, the strong global symbol, has a value to begin with, and that's why it's called strong, which is kind of weird. And then there is the extern int ext. In this case, if this function is used somewhere else or like declared somewhere else, it is basically telling the compiler that this function, this specific variable exists in other file. Go fetch it for me, okay? So when should we be using the global type name? I have mentioned that before, that using global variable is not safe, but there is one time you should be using, and that is when you are declaring structure. Structure is kind of like class. I'm not going to get into it too much in this lecture. I will be explaining it later on when we are explaining structure. But for now, I'm going to say is whenever you are declaring structure, it should be a global name. If it is like local or inside some sort of like function or something like that, it is fine, but like that's not how you should be using structure. I mean, that also works with function as well. So data types are typically needed throughout an implementation, so it must be global. Okay, the type declaration is usually placed in a suitable header file, so it can be included as needed. There will be assignments where you will see how the functions are declared and why they are necessarily like declared in that manner. Okay, so for example, in case of like function name should be global. Okay, you can actually declare function locally, but in that case it becomes very limited. Okay, used for any function that needs to be called from other modules, very common. Place function declaration in a suitable header file. Okay. So for variables, it is never a good idea to use global variables, but the option exists for you. Unlike types and functions, variables are mutable. Making a variable global allows modification to it to be made from anywhere else. So this is how a structure declaration looks like. Here we create an array to index of a collection of records. The index uses objects only make sense locally, so the file is local type. So well, honestly, I don't think these are going to make much sense to you because you probably don't have any idea of what structures are. I'm going to cover this more when we are going through the structure lecture. So I'm just going to avoid it for now. I'm going to cover it later on. Now let's take a look at the how functions like file scope works. So this is used for any function that needs to be called only from the current module. Place function declaration suitable.c file and make the function static. So this is the same idea as like private functions for private methods for classes. So the idea over here is think of the whole file as a class. Okay, so and you do not want this specific function to be outside of this class. So in that case, you put static before it. So the idea is simple over here. Static is kind of like the private declaration for a class, like inside a class. Okay, that's the basic idea. So that's it for this lecture, and I think I'm going to make a additional video for this just to show you how the storage, like different duration and scope and linker actually works. This was more of a like formal definitions and stuff. Maybe it was very vague. I am going to make another video just to explain like the whole concept and everything. So yeah, I'll see you in the next video.